For Unit 5, Lesson 4, titled Predicting Products of a Chemical Reaction, our objective is that students will be able to predict the products of a chemical reaction by classifying the reaction and writing proper ionic formulas. So if our skill is that we want to be able to predict the products of a chemical reaction, you basically just be given the reactants, which are lithium and calcium chloride, and you'd be asked to figure out the products. You need two skills in order to be able to do this. First, you need to be able to classify the reaction as one of the 5 types that we went over yesterday. And then the second skill that you need is this thing that will just not go away. Nomenclature. All right? Those are the 2 skills you need. Write those down. We're going to practice them. So we're going to take this reaction type by reaction type, the first one being synthesis reactions. As a reminder, they are when 2 substances combine to form one product. And there's 2 key points, but I'm going to go over them as I go over an example. So let's say we have some lithium reacting with some oxygen gas, and we are trying to predict the products of that chemical reaction. The first thing you need to do always is classify the reaction. I know it's a synthesis reaction because it's an element reacting with an element. So I know that the only thing that those 2 elements can do is come together to form one product that contains lithium and oxygen. But I am not done, because key point number 1 says that I must create a neutral compound by finding charges and balancing them. Okay? So lithium has a charge of 1 plus, and oxygen has a charge of 2 minus. That is definitely not a neutral compound. That would tell me that I need 2 lithiums for every 1 oxygen, and that is a neutral compound. So what you might have noticed here is I cannot just carry this 2 and put it over with the oxygen over there, okay? You don't do that. It doesn't create a neutral compound, so you really, really, really need to resist the urge to automatically write that 2 there. My last point is that, notice, I didn't balance the chemical reaction. I realize this is totally unbalanced, not the focus of today's lesson, so it's okay that there's 2 lithiums being produced, but only 1 going in. We could balance it if we wanted to. Alright, so we're going to try an example problem here. If you feel like you get it, you can pause me, try it, and then fast forward through the whole explanation I'm going to do and just check your answer. Alright, save yourself some time. If you're unsure, you can listen through. I'm going to ask you some questions. We'll break it down. So we have 2 reactants here, aluminum and fluorine. And my first step is always to classify the reaction. So you're asking yourself, what type of chemical reaction is this? And hopefully you said synthesis because it's 2 elements. The only thing, elements. The only thing that 2 elements can do is combine to form products. One product. Alright, but my job is not done. I must check to see if this is a neutral compound. So go ahead and find the charges. Pause me. Okay, here we go. Aluminum is 3 plus and fluorine is 1 minus. So how many of each of those do you need to get a neutral compound? I need 3 fluorines to get 1 aluminum. Alright, that's my answer. I don't need these charges anymore. They were just my work. So my final answer is that. And again, I realize it's unbalanced. It's okay. We could balance it if we wanted to. So the second type of reaction that we're going to go over is the single replacement reactions. Remember that that's when an element reacts with a compound and the 2 metals switch places to form a different element and compound. So let's just do an example here. Let's say lithium reacts with calcium chloride. What are the products that would form? Again, the first thing I want to do is classify it. It's a single replacement. Here's my element reacting with my compound. And I know that these metals are going to just switch places. So I'm going to write that down. The calcium switch places with the lithium and bonds to the chlorine. And key point number 1, remember that product needs to be neutral. So I need to look at charges. Lithium is 1 plus and chlorine is 1 minus. So they end up balancing each other out in a 1-to-1 ratio. All right. Calcium can stay by itself right here because calcium's a metal, so it can definitely sit by itself. What cannot sit by itself and just stay as a single element are these right here. And a cute little way to remember them is it's pronounced Huffenbrinkel. So these are the elements that would form binary molecules, meaning when I mean binary, I mean like H2, O2, F2. So you can see all the elements there: hydrogen, oxygen, fluorine, iodine, nitrogen, bromine, chlorine. So I'm going to have you try an example here with hydrogen reacting with magnesium chloride. You can go ahead and try it, pause me, and then you can fast forward to the answer to see if you got it right. And if you didn't get it right, then you want to just rewind and listen to my explanation of the answer. So go ahead and try it now, please. All right, and I'm going to go over the answer here. This is a single replacement reaction where hydrogen is reacting with magnesium chloride. This positive ion switches places with the other positive, and I know that I'm going to get magnesium and HCl. All right, I have a compound there as a product, so I need to make sure it's neutral. Hydrogen is 1 plus, chlorine is 1 minus, so those balance out, and I can leave it like that. I did not carry that 2 over. Don't do it. Resist the urge. I also didn't carry that 2 over. Resist the urge. Okay, and then I do a double check. Can magnesium stay like that, or is it Mg2? And it's a metal, so it sits by itself like that. And there is the answer. Okay, on to the next type of reaction, double replacement reactions. And again, as a reminder, we're talking about a compound reacting with another compound where the metals switch places and we form 2 different compounds. So here's one compound, here's another compound, and that's how I know it's a double replacement reaction. If I know that, my next step is to switch the metals. Okay, metals always come first, so I know I'm going to switch those 2. So let's see, we have Na and F, and then we have Be and Cl. I am resisting the urge to bring the subscripts over. Okay, all my subscripts are 1 to start. Now I have to figure out how to balance those. Charges, always. Sodium, 1 plus. Fluorine, 1 minus. Beryllium, 2 plus. Chlorine is 1 minus. So I can see here, this compound is good. 1 plus and 1 minus balance out, but this is not. I need 2 chlorines. I'm going to have to squeeze it in. 2 chlorines to balance out the 1 beryllium. All right, and there is my final answer for that reaction. All right, so I'd like you to try an example here, and if you feel good, go ahead, pause me, and then fast forward to the end and see if you got the right answer. If you didn't, again, go back, listen to the explanation, okay? So go ahead and try this one. And I'm going to go ahead and give you the answer. It's a double replacement. Compound has to be double replacement. Okay? The metals switch places. And I actually hate using the term metal because really it's positive ion, which is generally metals. The one exception is this hydrogen, which is positive. The positives switch places. And I have HCl plus Al, Br. I don't carry the subscripts over to the product side, but now I'm going to balance the products. Okay, so I did the charges. This compound is neutral, so that's fine. This one is not. I need 3 ALs, I need 3 BRs to balance out the 1 AL. So that's my final answer for the products. All right, so I actually saved the easiest one for last. So take a deep breath. Combustion reactions, where hydrocarbons react with oxygen gas to form carbon dioxide and water. Here's the good news, my friends. These are always the products. All you have to do is recognize that this is a combustion reaction, and all you have to do is tell me, hey, it's carbon dioxide and water. Always. That's it. That's why it's the easiest one. Doesn't matter what combination you have here in terms of the hydrocarbon, you're always going to have oxygen. There you go. We're not even going to do a practice problem. Just write that down. It's the easiest one. All right, so that wraps up this lesson. If you cannot classify reactions, or you have a hard time with nomenclature, writing these chemical formulas, you have to go back and watch the videos. There's just no way that you're going to be able to do this. All right, so take the time, go back, come after school, do what you got to do to be able to do this.